Hey everybody, happy Tuesday, hope you're doing well. Alrighty, we are moving on now to functions here from chapter 6 in our Xi book. So let me fire up PyCharm here. We'll get moving on that. While that loads, I'm going to get some more coffee here. Good afternoon, Trumpet Man. Thanks for coming along. Hey, is that IIO fire? IIO fire or Leo fire? Is that an L or an I? Alrighty. So we're going to be adding Leo fire. Okay, Leo fire. Awesome. We're adding new tools to our toolkit here. So we're going to talk about this idea of functions. Now, functions are fantastic for a variety of reasons. Particularly, I think the one that gets the least amount of credit, probably my favorite reason for a function, is that we got to start putting more names to things that our code does, which I think is the coolest thing. And that's this idea of being self-documenting, right? If your variable name shows what it's storing and like what it represents, then it's much more meaningful. So that way you don't have to leave a comment and say, hey, this is a variable for something else. Right? So when we write functions, we get to put a name to what the code is doing, which is fantastic. Call this chapter, oh my goodness, I forgot already. Is it chapter 6? Chapter 6 functions, here we go. Chapter 6 functions. All right. So we've used functions already. We've done things with functions without really realizing too much about it here. And that's okay, and that's great, and that's part of the reason why we have this awesome library of code built in. Right? We want it, we want to be able to take advantage of code that's already been written here and not have to reinvent the wheel. So we said, hey, if we can import random, and we can get random numbers. So we did like, hey, let's guess a number here. We had a random number equals random.randint given, right, or how high do we want to go? How about 100? Right? So Randint is a function here. It's going to generate a number. And number, sure, let's go ahead and print. Oh goodness, it's still like loading way slow behind the scenes. Let's go, PyCharm. Why is my computer so sad with me? It's still loading. Come on. I need to kill more things? Do I have too many processes running? I think I have too many. What else can I kill? I think my computer's just getting slow. It's like 2.5 years old, which is sad that laptops just don't last as long as they used to. It's kind of disappointing. Yeah, what else are you doing? Yeah, just PyCharm being slow. Oh, my anti-malware. There we go. That always slows things down anytime it's doing virus scanning. That's lovely. Thanks, Windows Defender. Slow things down for me. Still going. Still going. Still indexing. Yeah, what is it? Indexing Python SDK. But it shouldn't have to do that again. That's super weird. Maybe it feels like it's a Monday. Just wants to be nice and slow. So anyway, Randint is the function that says it will give you back a random number from 0 up to and including the number you ask for. That's a function here. So we've used built-in functions. Like input is a function. When we said I want to get an input here. So like the user's number is an input of, enter number. So input is a function. Now with input, we have to give it a value here to say, okay, spit this out on the screen. With Randint, we have to give it a value that says, okay, I want a number up to this value here. And they return a value. So we can assign what comes back from that function here. And we can print out the numbers. My goodness. PyCharm. This is, okay, I really need to just open PyCharm earlier. I'm sorry. Okay, so we got our random number, we got this function, so we've used them before, and things like int, right? Technically not a function. This is doing a conversion here. Slightly different, but essentially we're calling it, it's kind of like a function here. No big deal. So it says, hey, give you a string, and I'll turn it into an integer. There we go. Let's see, make sure it runs here. Make sure our code runs. Oh, goodness. Randint. Missing one required positional argument. B. Oh, dear. Data spell. It doesn't ring a bell, Leo Fire. Doesn't ring a bell for me. Did I screw up Randint? From A to B. Random dot Randint. Oh, okay. So, all right, from 0 to 100. There we go. Let's go from 0 to 100. Enter a number, 50. The random number was 86. We did not guess it right. Bummer. Okay, so we've used some functions here, and it's nice because it's also reusable. Anytime I want to do the same thing, like pick a random number here, is right here. Right? I can reuse this bit of code. Ooh, a new IDE. That's cool. No, I've not checked that out before. Sounds cool. Is it similar to? Oh my goodness, my head not working. The is it the worksheets in? Man, nothing in my head. It's not Spider. It's not Anaconda. There's a lot of different IDEs. Wow. I apparently need some more coffee. It'll come to me in a little bit here, what that other tool is, that we have worksheets. Jupyter. So like a Jupyter worksheet kind of thing. Maybe I know those are pretty data science focused. They don't have to be, but we tend to use them for that. We've got functions. So if we want to define our own function, right, we can make our own. We can make our own little bit of reusable code. And we put a nice name to it here. So something like, hey, let's, the silly little example here is converting from Celsius to Fahrenheit. So to make a function, we have to use our def keyword. So to say we're going to define something here. Uh-oh, I'm lagging. Oh dear. Let's see if it comes back. Maybe. All right, the bitrate looks like it came back, but it's still showing lag. Drop frames. If you can still hear me, it's probably okay. The drop frames will be a little bit obnoxious, but it won't be the end of the world. All right, yeah, I think we're back. Sorry about that. All right, so when you want to create your own function, you use the def keyword to say, hey, I'm going to define a function, and we'll call this convert F to C. Normally, I would say you should spell all these things out, Celsius here, but spelling Fahrenheit, sure, that's probably close, sure. We'll spell it out here. Fahrenheit to Celsius. Oh, is it telling me I'm spelling it wrong? Rename to... All right. How do you spell it? All right, it's close enough. Celsius. My apologies for spelling wrong here. So if you want to convert from Fahrenheit to Celsius, we need to give it the Fahrenheit. Right? And then we put a colon in. Right? Anything after the colon belongs to the function here. Just like when we did our if blocks or our while blocks, anything tabbed in underneath the colon belongs to this. Fahrenheit. Each. Fa? Ah. Fahrenheit. Sure. English is fun like that. Of course, there's a silent H there. All right, so if you give me a Fahrenheit value, I can convert it here. Remember, so to convert from Fahrenheit to Celsius, we get our Celsius is going to equal the Fahrenheit. And now this argument here, it's called an argument or a parameter. Technically, when you define it, it's a parameter. And when you give it a value, it's an argument. It's like enter a number is an argument. 0 and 100 are arguments. Inside the method, it's a parameter. Most people use it interchangeably because we all understand what it means. But I can use this value inside of my function here because it's going to get a value. So when you call this function, like when we called Randint, you had to give it two numbers, the low and the high. When you call convert Fahrenheit to Celsius, you have to give it the Fahrenheit value. So Celsius will start off as Fahrenheit minus 32. And then Celsius will change to, okay, rename to, oh, it just wants a capital C? Is that all? No, O and S there. S. Celsius. Celsius. Okay, instead of a C. They sound the same. All right, so you subtract 32, and then you take 5/9 of it. All right, so the current value then, right, we can divide by 9, right, and then we can take Celsius and multiply by 5. Sure, we could do that, or we could do it all in one step, right? We could just multiply by 5 divided by 9. Right? Sure. Right? Any way you want to take 5/9. Right? And the way I remember this always is that freezing point, for those of you who love the Fahrenheit system, is 32, and in Celsius it's 0. So you subtract the 32 first, and then you get smaller. Right? So that's how you can remember that. And then the boiling point, remember, is 212 for some reason. Lots of reasons, actually, why Fahrenheit is such an awful system. And in Celsius, it's 100. So you know you're getting smaller. If you're going from 212, you have to go smaller, so you know your fraction is smaller here. And then if you actually do the math, right, 212 minus 32 divided by 9 times 5 puts you at 100. Right, so we can check that one real quick. And then we can return a value, Celsius. Celsius. So return is the keyword that says give back a value. So this function will return a particular value. So we'll say, how about enter a temp in F to convert to C. Okay, we'll get the value. We got their, I don't know, let's call it user's number is fine. It doesn't necessarily need to change. Or I don't know, sure, how about temp in F? And then we can say, I want to create a new variable. I'm going to have a temp in C is going to be equal to whatever I get back from convert to Fahrenheit given the temp in F. So if I give it the temp in Fahrenheit, it will do this calculation, do the arithmetic, return a value that then I can assign to temp in C. You can print the temp in C. Right, and maybe even do like a nice little formatted string here. That temperature in Celsius is, do a little pretty substitution here, temp in C. Cool. So let's give that a run. So let's try then, right? So if we do 212, it should come back 100. Looking good so far. Run it again. If we do 32, right, we get 0. Life is good so far. Just something in the middle here, like 75 degrees, puts us at 23 point whatever Celsius. Sure. Cool. And we could even do that rounding too if we wanted to, right? Add in the pretty formatting here. So that's the 0.2 F for a floating point value. So you don't get so many decimal places. So 75 degrees, 23.89. Sure. Seems to work okay. So that's a function here that we've defined. Again, we could have just done this arithmetic here. So we haven't really gained anything. But what we're getting now is we're putting a name to what's happening. Right? We're naming our function. We're saying, okay, if you want to do this bit of code, call it convert Fahrenheit to Celsius. Puts a name to what's happening. So you don't actually need to see what's happening inside the code to read, oh, okay, I'm going to convert here. Puts a nice name to it. And then if we want to do this more than one time, right, I can just use the same function more than once. Right? Our general rule of thumb here was anytime you have the same code more than once, you should feel bad about yourself. Right? So by making a function here, we can avoid having repeated code. So we can feel better about ourselves. We feel like we're a decent developer, a decent programmer here. Right? So functions put a name to things, and they help us reuse that amount of code. So those are two great reasons to use them. Now, functions don't have to return values. You can also just have functions that just do something. We could say like print hello. And they don't even need any arguments either. If you don't want any arguments, if you don't need to give it some value for it to act on, you don't need to give it any. So print hello can just say print hello there, I'm a computer. Let's do that in single quotes so I can have the double quote mark. Oh no, double quotes, and that can be a single. Why did I do a double quote there? That's a weird shift. There we go. Hello there, I'm a computer. And if you want to print hello, you just call your function. You say print hello, set a parentheses. And the parentheses here are important. This is telling it to run the function. Right? Technically, oops, where'd it go here? We can say print hello. without parentheses, and that's fine. It's just not going to do, it doesn't call the function. Doesn't do what we'd want it to do here. So sure, let's convert 32. We get hello there on my computer, and then like nothing. It doesn't actually call the function, so it's not doing anything, so we're not getting any results out. And then what's really fun is we can put this in debug mode. Right, so you put your breakpoint in here, you click in that kind of white gray space there, get your big red dot, and then instead of run, you're going to use debug. So you can right click and debug, and remember it's going to pause the program when it gets to that line. So we're waiting a second here. So we still have to enter our value. So sure, here's 50. Now it pauses, and we can see what our variable values are here. So we see, hey, temp and F is 50 right now. Now we've got a couple options. We have a step over, and we have a step into my code. Step into my code is my favorite one here. So if you want to go into the function and see what's happening, we're going to step into. If you don't want to see the function run, you step over the function. That's kind of why it's called step over and step into. So if we step into, we're going to see now that I'm tracking over on the left-hand side here. This is called the call stack, right? This is, I was at line 13 here. Now I'm at line 4 in the convert Fahrenheit to Celsius function. So Python is tracking behind the scenes where it left off so it can go back to where it came. So previously in our code, right, we would go top to bottom. And then we said, okay, let's go top to bottom. There's an if statement, so we'll run this block, or we'll run this block, or we'll run this block, whatever we can decide here, but it was still top to bottom. Then we decided to add loops. We said, okay, well, we can repeat our code, we can loop here, so we'd go top to bottom, but okay, here's a loop, go back a little bit, repeat, go back a little bit, repeat, go back a little bit, repeat, right, rerun that, but it was still top to bottom. Now with functions, we can actually jump around. We can say, okay, when you get to that line of code, go jump to where that function is, do that function thing, and then come back to where you were. So we need to keep this little placeholder and know where we left off, which is pretty cool. And then we can see now all the variables that we see are Fahrenheit and Celsius. We don't get to see this temp and F variable anymore. So if we come back to this module here, we have the temp and F variable. Inside the function, the only variables it has access to are variables that were declared or passed to the function. So there's this idea of scope. So scope is the technical term for where a variable can be seen. So the only variables in scope right now are the Fahrenheit argument that was given to it and this new Celsius that we've declared. And I can step through and I can see, okay, now we've calculated, we've converted, and now we're going to return here. So it was 50, right? Fahrenheit stayed at 50. We didn't change it. Celsius is now 10. Right? And we do our prints. We print. We're done. We can see it's 10. So when you step through, you can see that functions, right, they leave that placeholder. And then the cool thing is functions can call other functions. So I can define a print, how are you? And we can print, how are you? And then from print hello, a function can call another function. You can print hello from this function. So, Trumpetman, different places have different conventions around where functions are defined. So Python is smart enough to be able to go find the function in the file, which is pretty good. So if we say 50, sure. Uh-oh. Oh dear, I did the wrong thing. Print hello, call print hello. I was supposed to call print how are you. Notice it printed a whole bunch of times, and then it crashed. Right, we got a maximum recursion depth exceeded. We'll talk more about this recursion idea later. I just did a dumb thing, my mistake. And it was in an infinite loop, right? The function called itself, called itself, called itself, called itself, called itself, called itself. Eventually Python crashes if you get into those recursive loops here. So yeah, print how are you? Let's actually do the right thing here. So Python is smart enough to go find the function, which is pretty cool. So you can put the functions anywhere you want. Here, so they can be at the top, they can be at the bottom. Python doesn't care. Other languages, oops, sorry, right click, run, there we go, run, 50, uh-oh, It cares a little, It says, print how are you is not defined. If it's below where you're trying to use it, it's going to crash. So what Python does, remember, it's an interpreted language. It's not a compiled language. So the Python interpreter is going to read this file, and it actually reads it in order, line by line by line by line by line. When it gets to a define, it says, oh, sure, I'm going to load this, and I know I now have a function of this name. It's ready to go. Great. Then it starts executing. It says, do this, do this, do this, do this, do this, do this. Great. When it goes to execute print hello, it has not gotten yet to line 22 to read in and load this function. Goodness, I'm sorry for the lag. See if I can kill something else here. So as long as you're doing them in the order in which you're going to be used, so you have to define it before you can use it. Other than that, it doesn't matter. Yeah, there's nothing else running here. Is it just my network? Network should be fine. That's super weird. So as long as you define it first, so typically we'll put them at the top, right? Because that way they can get loaded first, and then we can go use them. Okay, so if I put it back up here, it's going to have loaded it before it gets used. Now, it didn't warn us when it was defined down below, which is a little bit obnoxious. But now when we run it, right, it's going to work here. But essentially, the order of the functions here doesn't matter, right? We can define either one, first, second, third, doesn't matter. Right, these will work. So generally at the top. So once we talk about classes, that'll be a whole other thing that happens. And then the order doesn't matter quite as much. But for our purposes, we're just going to put them at the top. It'll make life easy. Oh my goodness. Is the lag real bad, or am I just worried about nothing here? It says I'm dropping frames, but if the audio is okay, it's probably not too terrible. So I'm going to put my breakpoint in print hello, and I'm going to run this again in debug mode, and then we can watch it step into that one. So I'm going to step into my code. Here's 50. We're going to step into, and then we're going to step, and then I'm going to step into again. Now I'm going to see, hey, I was at line 21, then I was at line 13, print hello, and now I'm at print how are you, line 9. Right, so every time you call a function, it's just going to add to that call stack, so that way it knows where it left off when it comes back. And that's how it's going to work. So functions are great for things like that. We can do all sorts of cool things with them. So yeah, all sorts of fun examples there. Those are our user-defined functions. Yeah, we can print things out. So like when we did some of those exercises where we printed different shapes here, we can make a function for that, like a print triangle given a size. And then what we can also do then with a function is I can say, what character do you want to use? All right, sorry for the lag there, Triple Man. So if you tell me what size of triangle and what character to use, I can print a triangle of that given size and character. So I'm going to say for row in range size, so I'll get row 0, row 1, row 2, row 3, row 4, row 5. So I probably actually want to go from 1 to size plus 1, because I want one triangle each time. Right, so if I start at 1, or one character at the top, and then 2, and then 3, and then 4, because range is going to stop before it gets to size. So I want to go to size plus 1 here. So I start at 1, and then I can say print the character times the row. Right, the row will be row number 1, row number 2, row number 3, row number 4. And, you know, I'm feeling bad. I'm going to rename this one here. So I'm going to refactor rename. We'll call that row number. Okay, so the character times the row number. And now I can print a triangle. We can call print triangle. Let's do like size 10. And how about with the star character? Or how about a print triangle? And let's do size, I don't know, 7. And let's do the, how about a % sign for fun? That character. And we'll get 2 different triangles now. Oh, I got to stop the debug mode. Just run it here. Enter temperature. And now we get size 10 with stars, and we get size 7 with % signs. So our function, again, can take different variables here and do whatever we want it to do with it. It doesn't have to return something. Okay? Now the other fun thing you can do is if you want this character to be optional, we can do that. So you can say, hey, for my given function, I will have a default character. Here, so you say it equals a star. So that way, if you don't give me a character, I'm going to default it to a star. So I can just say, hey, print of 10, and it says, okay, hey, if you give me the first argument, that must be the size. If you don't give me a second argument, I'm going to give you a star. If you do give me a second argument, I'll use that as the character. So it's a default variable, or default argument here. Default or optional arguments. So you just say, hey, it equals this. Now the trick to that is they have to come after the other ones. So you can only do optionals or defaults after you have the required ones. So if I just call print triangle, and I try and give it nothing here, it's going to yell at me, because I won't be able to run that. It's going to say, hey, print triangle, missing one required positional argument, size. It can't run if you don't give it a size, because it's missing the required argument. They're called positional arguments. Okay? Now, the funny thing in Python, right? Remember, Python, we don't have defined types of values for arguments. Like if I say, hey, give me a size, I could technically give it like a string called 10. Now this is going to be funny and it's not going to work right here. Right? You can only concatenate string, not int to string. I mean, I can't range for size plus 1 if size is the word 10. The function itself doesn't care what you give it here. If I give it a string, or if I give it an integer, or if I get a floating point number, it doesn't matter. But it's going to crash because it doesn't work. So Python has a little bit of trouble sometimes with making sure you give it the right types of values here. So you got to be careful to make sure that you're going to get the expected type. And there's some ways we can work around that. And there's some things we can do to check for given types to make sure that they are what we expect. But you know, in general, you're going to assume people will do the right thing. Python is considered a trusty language. We're going to assume people will do the right thing for us here. We're going to trust they do the right thing. Oh, didn't I give it size? So that's the old one, right? Oh no, down here. That's this call here. So we can't. This doesn't work. We get an error. We get this type error here. Hey, we can't call print triangle. So let me just comment that out so it doesn't yell at us next time. Okay, if we can call our function, we can do these things. Excuse me. So the other great reason, right? So we talked about functions are great because you can put a name to your code. Functions are great because you can avoid repeated code. You can feel better about yourself because you don't have the same code twice. And the third reason functions are great is it allows us, when we're developing a program that's solving a problem, to break it down into smaller and smaller and smaller pieces. Right? I don't need to necessarily solve a really big problem all at once. I can solve small pieces of that problem, little bits at a time, and then put all those little pieces together. Kind of this modular idea, right? The technical term for that, it's one of my favorite technical terms. It's functional decomposition, which is like the greatest term to throw out if you're at a dinner party with your family or friends. Just say, oh yeah, I was so busy at school doing this functional decomposition, and people are just going to look at you like you're nuts. Which, I mean, you're in a programming course, you're probably some kind of nerd already, or geek already, and people are probably going to know that. But you get really funny looks when you throw out nerdy terms, geeky terms like functional decomposition, and it's really fun. So the sad thing is, my brother's a programmer, my sister's an engineer, both my parents are engineers, so like they don't even bat an eye when I throw out funny terms when we get together for Thanksgiving. My wife rolls her eyes at me. She studied early childhood development and went to become a teacher. So we're sort of opposite peoples, where I like the math and science and she's more the social science side of things. But you know, it's fun. And throwing out funny terms like functional decomposition is always good for parties. So if you can break down a big problem into smaller problems, it makes it a little easier to solve. Let's see here. Mathematical functions, calling functions. Yep, we've done that. Yep. Yep, cool. Functions, you can have any kind of code that you want inside them as well. So with like the triangle, if we wanted to do something about a certain size, we could check. We could say, hey, if Or like with our diamond shape, right? We only wanted odd numbers when we were printing out our diamonds. We could say, hey, if size modulus 2 is 0, right? So if I can evenly divide out the 2's and there's no remainder, then size must be even. I'm going to take size plus equal 1. Let's add 1 to it. Right? This will make sure I always have an odd number size here for my triangles. You can do all sorts, any of the other things. You can have if statements, you can have for statements, you can have while loops, you can do if else, any of those, anything you want inside your functions. Right? No problem at all. All right. Cool. So when we're looking at taking a big problem and breaking it down into smaller and smaller and smaller problems, right? This idea of that functional decomposition, we want to take something big, break it down, and then put nice names to things. We can essentially start defining the functions without actually knowing what they need to do yet. Right? So if we were to take a big problem and say, let's break it down. So just for fun here, let's take a look at, let me start up a new project here. We'll call this the project 2, I'll call it the stub here, because I'm going to put functions out there. Let me do it in a new window here. So we're going to put names to functions, but we're not actually going to write the functions. But what we can essentially do is write the shell of what needs to happen to solve a problem here. Okay, so let me zoom this in a little bit, and I'm going to pull this up here. Let's look at project 2. Let's see if we were to use functions, and again, it's not required for project 2, not required at all, but if you wanted to use functions, we could approach it in this certain way. Right, so let's take a look at project 2. Right, don't forget due coming up next week, Thursday, 3:30 p.m. Got a little bit of time still. Our new and improved retirement calculator. Okay, so we're going to only write functions here. Okay, so essentially, we're going to put all of our functions up at the top, and then we'll have something like, okay, so name equals get user's name. Okay, this will get the user's name and return it, stored here as name. So we need a function for get user's name. And for now, if you don't have a definition, it's going to yell at you. If you just leave it blank, it's going to be upset. It's not going to compile. So there's a special word called pass. Just means I know it's empty. I'll come back to it. Oh, great, Baymond. Yeah, it's checking for odd. That's an easy way to go about it. Just do the mod 2 sort of thing. Okay, so we'll get the user's name. Right, we'll do that. And then we need a get initial values for all these different accounts here. Okay, so let's start this way and we'll see if we can refine it here. So we'll have the mattress money, I don't know, or sure, equals get initial mattress money. Sure, and we can define a function for that. Again, pass, right? But we're just saying, okay, I'll come back to this. And then sure, then we'll have a bank savings, get initial bank savings, sure. And we'll define that one. The pass, we'll come back to it. Initial, right? Initial. Okay, and initial bank savings, and then bond savings or bonds, investments. I don't know, you can call it anything you want. Get initial. Now, hopefully you're thinking to yourself, like, what's different about all these functions here, right? If one of the reasons we like functions is that they reduce redundant code, what's going to be, I can't spell initial. My goodness, like 3 times in a row, initial? Okay. What's going to be different about the mattress versus the bank versus the bonds that we're asking them for? Well, really the only thing different is going to be, hey, like the thing that we ask for. How much money is in this particular account? So as you're writing this, hopefully you're thinking to yourself, oh, well, could we do better? Right? Yeah, we can do better. So instead of doing one function for each, I can say get initial money for type, and then you have to give it type. So if you tell me what type here, then I can get the initial value for that type. And then in each of these, I can say mattress, and then I can say bank savings, and I can say bonds, and then we can do a stocks too, right? Stocks. Oh, too many S's was the problem, right? 2 T's, yeah. Mattress. Okay, and then stocks, I don't know, sure, get initial money for type, stocks. Get initial money for type then, right? And all of these functions can be the same function now, and they will just use this argument for what is different. If the only thing is different in the same repetitive bit of code, we could turn that into a function with an argument. Right, so now we have initial money. Great. Cool. What else do we need? Their current age and desired retirement age. Sure, why not? Let's do that. So another thing we didn't get too much into with functions. Let me show you real quick here. When we looked at functions, you can return a value. So there's a particular rule, is that you can only return a single value from a function. Like when you hit return, you can only put one thing here. That's a rule of Python. Now, the way you get around that rule is you can cheat. You can say, hey, I want to return a tuple. Right? A tuple is one thing, it just happens to be a container. So you can return a container, which is one object, right, as two. So the convert to Celsius is not great. How about let's do another function here, like define, I don't know, rectangle, area, and perimeter. Given a length and width. So if you give me length and width, I can calculate the area and the perimeter. So area equals length times the width. It'd help if I could spell things right. Right, and the perimeter is equal to the length times 2 plus the width times 2. Right? Cool. And then if I want to give them both back, I can return as a tuple area and perimeter. Right? I can return a tuple of two different values. It's a container, a single value, tuple, which just contains more than one thing. Okay, so you can return a tuple. Now, this is common enough that Python will actually automatically do this for you. So it's telling me right now that I have redundant parentheses. I'm saying, please make a tuple of these things here. And Python says, yeah, I know that. If you give me more than one thing, if you comma separate the things to return, it automatically packs them into a tuple for you. So when I convert, get a rectangle here, right? So let's, I don't know, we can have a length is an input of, enter the rectangle length. Oh my goodness, I cannot spell, friends. And then a width equals an input. Enter the rectangle width. And both of these need to be integers, right? So int of that and int of the other thing, probably. I mean, maybe they could be floating point numbers, but ints are easy for now. Okay, so if I just say print, and then the rectangle area and perimeter given the length and width, I'm going to see both results come back out. Sure, if we do like a 10 by 20, we see 200 is the area, 60 is the perimeter. Right? That's what we'd expect. We get the area and the perimeter back out. Now, we might not always want to print it though, right? If we wanted to save those values, here's where it gets funny. I can say area, comma, perimeter equal this. This is called unpacking. So perimeter, there we go. It will automatically take a tuple and say, okay, the first thing becomes area, the second thing becomes perimeter. Or I could save it to a tuple myself. I can have an area and perimeter equals this result here. And then I can say, print the area, a little formatted string, area is, and then it's area and perimeter index of 0. Right? That's the first thing in the tuple. And then I can print the perimeter is index of 1 is the second thing in the tuple, right? This is the first item in the tuple result, and this is the second item here in the tuple result, right? Our area and perimeter is the result, what we're getting back from rectangle area and perimeter, right? Or you can assign them this way with this unpacking. So let me actually do the first way. This is the slow way, this is the fast way, the shortcut here. And we could print, let me do these same prints here with area and perimeter. Just call area and just perimeter. Right, we're going to get back the same results. So 1 unpacks it for us. The other one, we're just saving it as a tuple and saying, okay, give me the first index, give me the second index. So you can technically return more than one thing, but it's doing that by creating a tuple. Right? So the one thing is the container. So this single value tuple just contains more than one thing. So this is automatic. So Python, it knows that, oh, if you want to return more than one thing, it just packs them into a tuple and says, oh, here's your one thing back. It's kind of a funny concept, right? It feels like cheating a little bit that you can do that, but it's no big deal, right? We like that. It's perfectly fine. So if you can do more than one return thing here then, right? Where was our project 2 stub? Where were we getting at for that? We can say I could have an age and retirement age. Retirement age is equal to get current age and retirement age as one function. If you wanted to, you could have two different functions. You could have get age and a get retirement age as two different functions. Or you could do them as one, right? It doesn't matter. Either, whatever's up to you. Get current age, and then we're just going to pass, right? Do something here. Sure. Why is it unhappy here? Expected 2 blank lines. Got 1. Okay. Sure. Okay. Just trying to get rid of some of those errors there. It's upset. Okay, account. We'll call that account type. ACC, account type. Or account type. Okay. Oh, I changed the name of the method. Oops, I should have done the refactor rename, but this is quick. Remember, if you double click, it's going to highlight the entire word, which if we're doing this underscore, the snake casing, the entire word is from beginning to end. It's nice and smart. So I just double click to highlight the whole thing and then Control V for paste. I love all sorts of shortcuts, so don't worry too much about it. And now it's warning me it's not returning anything because we didn't return a value. That's fine. We're going to come back to it. If you try and do that assignment here, let's look at that too. Like, so our print hello, if we said, I don't know, hello equals print hello, and then I were to print the value of hello here, right, it's warning me it doesn't return anything. We're going to get back a funny thing here. 50. We get back 10 and 20. We get back none. This capital N, none. None is a null in other languages. It means it's not a value. There's nothing here. So Python lets you do it. It's warning us, thankfully, because PyCharm is smart enough to tell you, oh, hey, you probably didn't want to do that because it's not returning a value, but you're allowed to. Right? I can store the result of what comes back. So the other thing you can technically do, like you can just say return and just have nothing. And it just, as soon as you reach a return, the function is done. Okay? So it's the same thing. Returning nothing, returning none, it does the same thing for us here. All right, so we're looking at some of those function stubs here, right? We got their age, and then for each year until they retire. Okay, so then the next thing we need to do then, right? We got their age, we got the retirement age. We need to do some sort of loop until they retire. Right? And again, that's a pretty straightforward loop. While, I don't know, we could say like current age equals age, and then while age is less than the retirement age. I'm sorry, current age less than retirement age. Let's do something. Let's do, how about add? We're going to have to ask them, right? We have to ask if they want to add more money to any of the types. If yes, ask them which type. Add it to that asset type. Okay, so our stub might say then, ask user to add to asset type. And again, we probably don't need an argument here. Maybe we do, maybe we don't. That's okay. And we have the type here. Asset type. It's equal to, ask them if they want to add. So if they want to add, yes. If they don't, then no. Right? We could do something with that. So we need a function. Or maybe we ask them first, hey, do they want to or do they not want to? Sorry, just 1 second. It's piano lesson time. Goodness. Right, we can ask them if they want to. Right, or maybe we have some other sort of, like, because we're doing this, right, ask more if they want to be all done for the year. So all of this is happening, whether or not they want to add more. Oh dear, the Zoom link's not working for my daughter. That's super weird. So if we're going to be doing this in a loop then, right, so maybe maybe we have to ask them, right, if they want to have more. Sorry, give me 1 second. I go pop on and check out what's going on with my daughter's Zoom lesson. I'll be right back. I will say 5 minutes. I'll put on some music and I'll be right back. Sorry. It puts us at what 4:24 p.m. Be back in a second, folks. Hey, sorry about that. It's really weird. It, on her laptop, it wasn't taking the password, and then on my laptop, it just worked. Probably needs a reboot or something. Tech is fun like that. All right, so we're going to change this up a little bit here, right? We want to ask them, right, like if they want to add more money here. So we need to check to see if they want to add money this year, right? So maybe we'll say, add more this year is going to be equal to, do you want to add more money this year, given maybe the current age? Like you could tell them, hey, at this age now, let's do, if you want to do this thing, sure, we can make a function. again, you can call these functions anything you want, right? Totally up to us here. So we'll have current age. Again, pass, we'll figure that out, right? It's probably going to return a yes or no sort of thing. And then we can say while add more this year is equal to a yes. Then, I don't know, what asset type? What asset type? Right, get the asset type. Sure. And again, we could do some sort of cool loop in here too, right? Where we check, hey, is it mattress? Is it bank savings? Is it bonds? Is it stocks? That sort of thing. Right, return that asset type. And then we can check based on which one it is. Right, maybe even a method here. Add money to asset type, given the asset type. Or ask how much. How much to add to asset type, given the asset type. And then that'll be the, I don't know. Yeah, we could do that. Oops, we need to pass there. Given the asset type. Sure, right? So whether or not whatever they said, we can ask how much, and then that'll be the how much to add is that. Now, the tricky part here is if we have these values for mattress money, bank savings, bond savings, and stocks, and we need to change the value, functions are a little funny. So if we come back to our functions here, and just for fun, like in our Fahrenheit here, if I said, hey, Fahrenheit, I don't know, plus equals 50, just to see if we can change Fahrenheit. We're going to see what happens. So let me put this in debug mode here. There we go, and let's run it in debug mode. Okay, we're ready to step. We want to run that line. Yep, and then at the console, enter temperature, 50. Okay, now we're going to step into our code here. Now we see Fahrenheit is currently 50. When I step, now Fahrenheit is now 100. I've changed Fahrenheit. Okay, so our calculations are going to be screwed up. That's, again, we don't worry too much about it here. And I return, but now I come back. My temp in F here that we gave it is still 50. Temp in F is still 50, despite us changing it inside the function. So when you pass a value to the function, right, we're passing a copy of that value. We're not passing, here's the actual value, at least when it comes to integers. Okay, we'll look at some other things in a little while that change this up a little bit here. But I'm passing the value here. So when you pass by value, I'm giving you the value of this thing here, which was 50. I'm not giving you my actual variable where you can go and change it, right? Usually we can go and change Fahrenheit. But because that you have a copy here, right, this is passed by copy, this won't change the original. So if you want to do that, and you want to change a value inside the function, you need to give it back. You need to be returning it every time. So in our function here then, if we want to add money to a particular account type, if I do it inside a function, it's only going to change the value inside that function. So I need to either change the value and then return it, right? Or there's other complex ways you can change the scope of your variables, and we're not going to mess with that right now. So to do that, then I need to change the values and assign them back, which causes a little bit of trouble, right, if we're trying to do all these functions here. But that's fine, we can do that. So we can then say, if we wanted to, we can assign values back here. So I can say my mattress money, comma, my bank savings, comma, my bond savings, comma, my stocks here is equal to what we're going to get back from, add to asset type, given the asset type, and given the how much to add. So this function then needs to return, it doesn't even have access. We need to give it all of them here, right? If we give it the asset type, how much to add, we need to give it the current balances for all of them so that it can return the new balances for all of them. This is getting a little funky here, right? The mattress money, the bank savings, the bonds, and the stocks. So if we give it the current values, I tell it which one I want to add to and how much to add, it can go change them, and then it needs to return all of them. This function gets a little ugly here. Oops, no. That was supposed to be a pass, sorry. Pass, fine. Given the asset type, how much to add, and then bank saving, or mattress, money, bank savings, bonds, savings, and stocks. Right, it needs to do the arithmetic based on which asset type, right? We can check, hey, if it equals this, if it equals this, if it equals this, if it equals this, and then we have to return all of them. Right, so this one's a little tricky here, a little bit ugly, but it's okay. It's going to work for us. Not too big of a deal. But for the function to change the value, we have to give it the current value, and then it has to return the new value here. Does that make sense? So again, some of these might be a little bit too much here, right? Like asking what asset type and then asking how much and then doing it. That could probably all happen in one function, right? That's okay if we do that, no big deal. And then our loop here, we need to make sure the loop might be able to finish here. So we need to reassign, do you want to add more money this year? Okay, to what type, how much, and then actually add it here. Okay, so what asset type, right, is going to be asking the user for some input and returning the result. Asking how much is going to ask for some input, return the result. This one's just going to do something. Like it doesn't need to return, it's going to return those values, but it's not going to ask the user for anything. Right? This is just like the convert to Celsius. It just does some stuff and returns, and it's done. There's no interaction with the user, where these methods can interact with the user. Right? They can say, okay, what asset type do you want as an input, and return the result, that sort of thing. So again, you maybe convert all those to a different one here. So just as an option here, like ask what asset and how much to add. Maybe that does all of this already, right? So then we just give it then current values here. If we just give it current values then, right, we could do this all in one and just assign the new values. So instead of all three different methods, all of it at once. So again, this is where it really comes down to an art more than the science of computer science. There's different ways to design it, different ways to break problems into small pieces here. So if you want to do one step, the next step, and the next step, great. If you want to say, okay, let's just do all the steps here, great, you can do that too. Equals here, right? Ask the user what asset and how much to add. Perfectly fine, right? Either way will work for you, just depending on what you want to do here. So again, it's just an option. So we'll add that function here, but we don't necessarily have to use it. Sorry, and it wants more lines here. It likes 2 lines after every function, just for reasons. It's just a convention. Okay, so either way is going to work for us. Either way we want to break those functions out, it's fine. And then, okay, do you have more money to add this year? Great. And then again, that same sort of thing, we're going to do, take our balances, and instead of ask how much, right, we're going to add yearly interest or something like that, or returns, add return on investment, return on investment, given all these values. Now, the mattress money we know is not going to change, so we could probably cut that one out, right, because that one doesn't change every year. Like, you can add to it, but there's no return on investment there. Come on, new lines. But if I give you the bank, the bonds, and the stocks, then we can reassign those values then, right? Mattress money doesn't have a return on investment. Sure, but the return on investment then could take current balances, add to them, and return the new values back. So we can define, sure, and again, I'm just going to pass. But it can do that thing, right? We'll add the values then. Oops, that happens after this while loop is done, after they're done adding more that year, right? As much as they want to add. Sure, I can add to stocks, I can add to bonds, I can add to my mattress, I can add to my bank savings. Maybe I forgot I wanted to add to stocks again. Sure, whatever. We're going to do that this year, right? And then we're going to go increase the value for each type. And then, once we're done, display final balances, to final balance, present value, right? All that finishing stuff we did before, we can then go do that. So after that loop is done, right? Once we've reached our retirement age, then we can do that function, right? Or print final balances or something, or calculate, so future value, right? Future value equals a calculate future value given, I don't know, we probably need a total value. Value is my bank, my mattress, plus my bank, plus my bonds, plus my stocks, right? So given the age, given the retirement age, because we need to calculate that, how many years inflation, right? And the total value. And maybe we just say print, I don't know, we could just do our own prints here, you know. Print. Values at retirement age. Right, you know, go finish that. That's not there here, but then calculate future retirement age, future value. No, I'm sorry, that's present value. Oops. Calculate present value. Present value, that's our present value. So we can define that one. Calculate present value. Pass. Right, so given these, right, we can calculate how many years it's been, adjust their total value, right, and then return that value as our present value. Does that make sense? So we can take this big problem and break it down. So now I have a bunch of functions here, but like this is essentially the code here. Like there's not a whole lot happening here in our program. Right? It's all, we've broken it down step by step by step so that each of the functions has to do something here. Now, you don't need functions to solve this problem, right? Where you haven't really, it's not required, but it helps us kind of put a name to what's happening, and it helps us avoid repeated code. It's like getting initial balances, getting additional balances here, adding balances. That's all the exact same thing every time. So we're just putting a nice little name to it here. And now we've taken that big problem, we've broken it down step by step by step by step. So now I can just solve, okay, how do I do this? 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 And I can do one small thing at a time. Pass means I know it's empty, I'll come back to it. Does that make sense for how we can do this functional decomposition? Right, that's essentially the second project, but now here's all the functions. Again, you're welcome to use this if you want. You know, there's a little bit of more to it, right? This, you know, the random values here and increases and things. It's not done, but now I can, okay, here's that one step, right? That make sense? We can now solve the smaller problems one little bit at a time. Okay, so that's the first part of functions. We'll come back on Thursday and we'll talk more about functions. There's a lot more to it here. We didn't get through all of it, but we talked about stubs here, right? This is the idea that, okay, I wrote a bunch of functions. They're not done, but I have an idea of what it's going to do. Here, so let me go add our method here. We'll just say left off at 6.8 for next time here. So I'll go commit this stuff to GitHub. And we can pick it back up with section 6.8 here and then finish talking about functions on Thursday. Any other questions, thoughts, or concerns? How are things going so far? Again, I only really see you folks in person on Mondays. If you wanted to come in person, if you're doing the remote, that's fine too. You don't necessarily have to come in person, but that's a good chance for me to come ask questions, talk about the lab. If you have questions about the project too, that's also a good chance to come and talk with me. This is functions part 1, project 2 stub. We'll commit and push that. Okay. Yeah, I think we're doing all right. Let's see here. Come on. Is it going to cooperate? It's not going to cooperate with me. That's okay. It's just going slow. We put on the ending screen here. Wow. Got real laggy. That's crazy. And we'll go send off a raid somewhere in Twitch land for fun, because that's always fun here. And we can go from there. Let's see who's around. Ooh, go do some chemistry. Chemistry is always fun. We'll go raid Professor Burrows here. We'll head over that way, go say hi. You folks take care. Let me know if there's anything I can do for you. If not, I'll see you here on Thursday. Take care.